Well, hi all. I'm Brian, and today I'm excited to talk with you about how we at the Philadelphia Inquirer used metric flow and the DBT semantic layer to centralize our metric definitions and enable better self-service workflows in our organization. So, I'm Brian Waligorski, lead data engineer at the Philadelphia Inquirer. We're a print and digital news media organization whose mission is to create useful, engaging, and ambitious local journalism to serve the Philadelphia region naturally, and to do so in a sustainable way, which is where we come in as a data team. We want to help enable the business make better decisions using better data. So I joined the Inquirer about 3 years ago. We started using DBT shortly after I joined, and we've been using metric flow and the semantic layer for about a year now. And to give you an idea of what I'll be covering today, first I'll go over how we got here, the problems, pain points, inefficiencies we're encountering, and their symptoms. Next, I'll talk about what we did in response to those issues. In particular, we took an opinionated stance on what self-service is and is not, or what we wanted it to look like in our organization, so that we got our intended outcomes. After that, once we had a metric layer in place, I'll talk about some use cases we activated for the DBT semantic layer, and how we're able to leverage a single source of truth for our business metrics. Then I'll go over what we learned in our year of working with this new metrics layer, and how we plan to activate it in the near and medium term. And then finally, I'll leave time at the end. You can come up and we can talk more about metrics and the semantic layer. So getting into it, how do we get here? What were the problems and their symptoms? And I think the problem is one that is hopefully resonates with many of you. And that is that our stakeholders have common recurring business questions. Here's one taken directly from our Slack instance. Hi, is there a dashboard where I can view homepage traffic by day in a chart? And as you can imagine, we're a digital news media organization. Homepage traffic by day, one of those KPIs that a wide variety of stakeholders are invested in. So it's a sort of question that we're asked frequently. And fortunately for us, as mature users of DBT, we're able to answer that question using the data in our warehouse. We have fact and dim tables that are modeled that can give an accurate answer. However, delivering insights from our warehouse requires SQL skills and contextual knowledge. And that tends to be locked away within a member or members of the data team. So there's a bottleneck there because someone needs to know that the business term homepage traffic translates to a very specific SQL statement, maybe something like select star from fact events, event name equals page view, and title equals home. But someone needs to know that that translation is what is required to give an accurate response. So someone or something needs to be making the translation from the business language of your organization to the SQL language of your warehouse and your underlying data models. And the issue for us, it was that it was a someone or a series of someones doing that translation anew every time. Whereas it would be much more preferable if it was a mechanized something doing that translation. Moreover, we lacked canonical ways to calculate key business metrics, which led to discrepancies in our data and decreased trust in our metrics. So for example, about a year ago, I was auditing our models, and I found that we were calculating total page views in two totally different ways. So depending on what report or dashboard people were reading, they might be looking at one of these two derivations of page views, comparing with other people, might be seeing different numbers. These inconsistencies cause distrust in our data. So to engender trust, we knew we needed a canonical definition for a page view enforced somewhere. And additionally, the ad hoc nature of these requests can be disruptive. Think a Slack ping or the dreaded after-hours Slack DM. And I share this meme because I think it gets at what people's expectations of a data team are, or what many people's expectations of a data team are. And that is this tip of the iceberg, pulling a number really fast. And that should be true to some extent. You should be able to pull your key business metrics without an excessive amount of overhead. Or technical complexity. But what that doesn't get at is all the stuff happening under the surface of a data team member's day-to-day work. the types of work that requires sort of deep focus and uninterrupted concentration. Exactly the sort of things that get interrupted when you get a Slack DM asking for an answer to a business question. So I think one of our intentions is to make that tip of the iceberg as big as possible, to be able to pull as many numbers, to pull a sufficient set of business metrics with low overhead. That way, it frees up capacity for our data team to do all this high impact work happening under the surface. So how did this problem manifest itself? Well, to better service these data requests, our team built and maintained a large number of denormalized aggregated data marts and dashboards. So just this presentation layer directly downstream of our fact and dimension layers, we were joining tables together, doing aggregations so that they can be directly consumed by arbitrary downstream tools. And this was ideal from a governance perspective because it meant that our business logic and our technical logic was in a source-controlled system, i.e. DBT. But from a code complexity standpoint and support overhead standpoint, it was pretty painful. It added hundreds of lines of boilerplate code to our SQL. Think null handling, joining to date spines, making sure you're doing full outer joins correctly. The sort of code that as you extend upon it and expand upon it, you find yourself copying and pasting large blocks of code. And as you can imagine, when you're copying and pasting large blocks of code from one place to the next, you're opening yourself up to a lot of error, and that's exactly what we experienced. This sort of denormalization layer was where probably our contained most of our most brittle models, the ones that created the most unpleasant surprises during after our ETL jobs ran in the morning. Additionally, these custom SQL models didn't necessarily make things more consistent. One example, we had a dim users table with 2 foreign keys to customer ID and user ID. But in our denormalization layer, we found that we were joining out to the same table using customer ID sometimes, using user ID other times, but with really no rhyme, reason, or consistency. So we still lack canonical ways of figuring out how these models related to one another and joined together. Some other issues are that our stakeholders would often just copy dashboard data into spreadsheets, maybe something that many of you have experienced as well. So it illustrated that we weren't providing the correct interfaces or the most efficient interfaces for our users to do their jobs. And then finally, iterating on these deliverables required additional modeling work. Say you have a dashboard where you want to slice or dice by an additional column. Well, in order to service that request, at least in our case, you needed to go back to the modeling layer, add that column by editing the SQL. As I mentioned in the previous slide, those were exactly the sort of workflows that were so error-prone. So as you can see here, we had a set of interrelated and compounding problems that illustrated 2 major needs. One of which is that our data team needed to formalize and centralize its business metrics. And this sort of rhymed with where we were 3 years ago when we started our journey with DBT. At that point, our data team needed to formalize and centralize its data models. So in some ways, a natural progression of our analytics engineering. And the second need was that our stakeholders needed better interfaces for accessing metrics. So no more, ideally, we wouldn't have users copying data from the dashboard into a spreadsheet, and worst case scenario, adding additional business logic of their own happening outside of our source-controlled system. We wanted to provide the sort of tools and interfaces where people could be most productive in their work. So what did we do in response to these issues and needs? Well, we wanted to alleviate the bottleneck where only members of the data team could answer business questions that required data from the data warehouse. And this required so we wanted stakeholders to self-serve some subset of the request and be able to iterate on some of those data needs. And this required taking an opinionated stance on what self-service is and is not, because it's sort of a loaded term in the industry, and at least in our circumstances, we wanted to be very deliberate about how we defined it. So a few things that we asserted self-service should not be and is not. A BI tool. We wanted self-service to describe workflows rather than tooling or a particular set of tools. And moreover, we wanted to choose tools best suited for each use case. So instead of a monolithic BI or data tool, we wanted to open ourselves up to the opportunity for using things like data notebooks, AI chatbots, possibly BI tools. They would just be one portion of our data stack, embedded apps, and whatever the right tool for the job was and for the use case. Additionally, we said that self-service is not going from analysts create dashboards to analysts create dashboards, but faster. We found that this doesn't sufficiently address the analytics bottleneck that we were experiencing. Still, if the main reportable is a dashboard, you still need someone to develop that dashboard, and at least in our circumstances, that fell on members of the data team. So the bottleneck was still there. And also, perhaps more importantly, we found that it was detrimental to data fluency and democratization. Think back to that query I had in the very beginning from Slack. Hi, is there a dashboard I can use where I can view homepage traffic by day in a chart? And if you pick apart that query, you can sense a bit of separation between what the stakeholder is requesting, a dashboard, and what they actually need to do their job, which is an answer to a business question, homepage traffic by day. So one of our intentions of this effort was to remove some of that distance between stakeholder needs and requests and get to the crux of what they were trying to accomplish more quickly. In contrast, we made some assertions about what self-service workflows should look like. And self-service workflows should allow stakeholders to answer questions without knowing the underlying data model implementation. That means not knowing what the foreign keys are for a given model, the primary keys, whether to join two tables together using a left join or an inner join. Ultimately being able to interact with the data without knowing how to write SQL or any other data language. Additionally, self-service workflows should enforce a single source of truth for metrics. So contrast that with sort of the legacy approach where metric definitions are configured in each downstream tool. We wanted our metric definitions to be tightly coupled with the modeling layer and ideally co-located with it. And then finally, we wanted to direct focus to the business metric. So instead of people asking what is the best dashboard to use to determine daily active users, getting people to more frequently ask questions like, how many daily active users did we have? Again, getting to the crux of stakeholder needs. So recall the first need, formalizing and centralizing business metrics. And as fairly mature users of DBT and its transformation layer, using the DBT semantic layer was a natural choice. It builds on top of the transformation layer. Its metric definitions are tightly coupled with the model definitions, and you can co-locate them as well. In fact, you can put them in the very same YAML file as we did in our case. And it allows you to govern your metrics via a single source of truth on top of your transformation layer. And then recall that second need, better interfaces for accessing metrics. Well, with the semantic layer in place, we could leverage a suite of downstream integrations and demo a variety of different tools, each of which was designed for a particular set of workflows. The idea being that we would select tools best suited for each use case. And so that could be, again, things like BI tools, embedded apps, chatbots, notebooks, ML models, or even materializing your metric results back into your warehouse. So in sum, metric flow and the DBT semantic layer enable these self-service workflows. And over a period of time, we built out our semantic models, our metrics, our dimensions, joined them together, and we arrived at what is in some ways a holy grail of analytics engineering, this single enforceable source of truth for the organization's business metrics. And what follows is how we leverage this source of truth. So recall again this diagram of the semantic layer and how various tools build on top of it. What I'll cover is the particular tools we used, who used them, and how they were used. So in our case, for BI tools, we used a modern data and analytics tool called Steep. For spreadsheets, we used Google Sheets extension for the DBT semantic layer. For AI and large language models, We're still actively evaluating that space, but I have some stuff to share at the end. For data notebooks, we used a tool that I'm sure many of you are familiar with, Hex. We used their semantic layer cells. And then for those tools that didn't have a native integration with the dbt semantic layer API, we used a feature called exports, where things are materialized back into the warehouse. So I'll start with Steep, which is a modern data and analytics tool. You can think of it as satisfying a lot of the workflows that would otherwise be handled by a traditional BI or dashboarding tool. But our use case here is that our product managers needed a lightweight way to visualize key business metrics without the data team being a bottleneck for servicing these needs. So I'll replay that video. There we go. So what we did is we provisioned a few seats for Steep, connected Steep to the dbt semantic layer, and allowed our product managers to interact with our metric layer, similar to the way you can see here. I'll play it one more time. But you have your list of metrics on the left. You're selecting them from a simple pick list. On the right, you have your dimensions and your filters that you can slice and dice by. And you can see pretty rapidly you arrive at a visualization, hopefully an answer to your business questions, and are able to iterate on them. And speaking personally, I think the lightweight nature of Steep contrasts favorably with the more monolithic BI tools out there. The interface isn't so complex that you need analysts to engineer reporting content for this tool. Next is, again, a tool many of you are familiar with, Hex, data notebooking tool. We had already been using it heavily at the Inquirer for SQL and Python development and exploration. But the use case here was that our data analysts needed to reconcile semantic layer metrics against our legacy custom SQL aggregations. So as we were building out our metrics layer, we wanted to ensure that the metrics that the metrics layer was calculating was consistent with the numbers we were already reporting in our dashboards and other reportables, and resolve any discrepancies as they arose. And we did this using Hex's semantic layer cells, along with Hex's SQL cells. So to the left here, you can see an example of a semantic layer cell in Hex. Similar to Steep, you're picking your metrics from a pick list, selecting dimensions and filters, and to the right, you get your metric results in this tabular format. And if you're Hex users, you might say to yourself, this looks like a data frame, and that's exactly what this is. Data frame, it can be compared against any other data frame in Hex, and that's exactly what we did for this reconciliation effort. We would have a semantic layer cell like the one here, generating some metric results. Below it, we would have a SQL cell where we would write an equivalent SQL query to return sort of the corresponding metric values from our aggregation layer. And then a third subsequent cell where we would full outer join those two data frames together, make sure the data agreed with one another. And this integration in particular was a compelling demonstration of the semantic layer's capabilities, not least of all because it was a tool we were already familiar with and actively using. Next, we have exports and saved queries. And so naturally, there are tools in our organization's data stack that don't have a native API integration with the semantic layer. I'm sure there are tools in your stack as well that have that same profile. Think traditional BI and dashboarding tools. But we still needed to create and maintain data assets for those tools to consume. And we did that using this dbt semantic layer feature called exports and saved queries. And what that allows you to do is provide a YAML spec, much like the one here, and materialize those metric results back into your warehouse. So you're specifying a list of metrics, a list of dimensions, filters again. Once this is deployed to your dbt instance and orchestrated, it'll materialize either a table or a view in your warehouse. And then at that point, any tool in your suite can just consume that table as if it were, say, a dbt model. And yeah, this is very much preferable from a support overhead and governance perspective, because otherwise this would be the sort of, if we were coding this by hand, these would be those sort of denormalization queries that gave us so much grief that I mentioned previously. And speaking as a data engineer, plugging into our traditional tools was one of the most immediate value adds of adopting a metric layer as well. And then finally, we have spreadsheets, Google Sheets in particular. So our finance team needed metrics related to subscriptions. They're most comfortable working within pivot tables, within a spreadsheet. We would have our stakeholders where they are, with the tools they're most comfortable with. So we use dbt's Semantic Layer extension for Google Sheets to populate metrics directly into the spreadsheets. And that freed our finance team from having to, say, copy data from a dashboard into a spreadsheet. So again, very much preferable from a governance and usability perspective. And so given that the semantic layer is a relatively new feature, we learned a lot about it during our year or so of using it. So I wanted to share a few of those lessons and how we plan to use it or extend its use in the near and medium term. So the first is two complementary lessons. One is you want to understand how to maximize dimensionality as you're building out your metric layer. And so that means building off of a well-normalized transformation layer. And this is a piece of advice that any number of metric flow tutorials recommend. But the reason for this is that in contrast to a well-normalized transformation layer, a denormalized model creates inefficiencies that can constrain how one can interact with the semantic layer. In particular, it constrains, given a metric, it constrains the number of dimensions that you can slice or dice that metric by. So if you have a highly denormalized modeling layer in dbt already, you'll sort of want to plan to unroll or refactor some of those models in order to get the most value out of the semantic layer. And then additionally, you want to avoid aggregating and joining data in your models by hand, most of the time. And I point out aggregating and joining because those tend to be denormalization workflows. And crucially, metric flow is a denormalization engine. It is that something that is doing the translation from business language to SQL language. So if you're also doing that translation by hand, it's sort of defeating the purpose of metric flow to some extent. That being said, there are exceptions to every rule. This rule is no exception. There are sort of, say, final yard transformations that we needed to implement for our use cases that aren't sort of directly supported by the semantic layer yet. So we do have some bridge models in our modeling layer that can do that last bit of transformation to make some of our metric results consumable by any other downstream tool. Some additional lessons. You want to agree on naming conventions early. Some of the most illuminating conversations we had as part of this effort revolved around, what are we going to call things? Do we call it total users or total viewers? Because we had people in our company calling it both of those things. Total subscriptions or total conversions. So we needed to get representatives of all of our stakeholders in the same room discussing and negotiating what our common canonical business language is, which is really impactful and important work to be doing. And it wasn't lost on us that we had the opportunity to do this as part of this metric effort. And then finally, be flexible, be comfortable with being flexible. I feel like as a data practitioner, half of my answers are, it depends. And it was no exception as we were doing some of our designing and architecting of our metric layer. For example, we encountered this a lot. Should two different models be two semantic models, or should they be united into one model beforehand? Well, it depends. But fortunately, the semantic layer grants you a lot of flexibility. It's abstracting away SQL code into configuration. So whereas in the past, things that needed to be SQL changes are instead configuration changes. And at least in our case, we found that you could sort of trial and error, roll out and roll back configuration changes with much less chance of it being disruptive than, say, if you were editing SQL code. And so where do we go from here? Well, we'd love to use AI chatbots to answer common language business questions. For example, that Slack inquiry from the very beginning, we'd love for someone to pose that question to a chatbot. The chatbot queries the semantic layer API and returns a response. I think we're a ways away from that being ready for prime time, at least for our uses. But so that we're at the right place at the right time, what we've done is we've constructed a baseline set of realistic business questions for our organization. And every so often, we'll throw those against the chatbot tools out there. And it'll help us evaluate how much additional investment we would need to make in this tooling in order to sort of operationalize these chatbot tools. And given the sort of advancements we've seen just during this conference, I imagine that this will be ready for prime time, hopefully in the next few months. And then next, we want to enable metric observability and anomaly detection. We want to know proactively when our key metrics spike and dip, and we want to know why they spike and dip. We want to know what dimensions and what dimension values contributed to these spikes and dips. Not something that we've proven out so much just yet, but it is a use case at the top of our mind for us. So there you have it. I enjoyed sharing this experience with all of you. Speaking as a data engineer, we were some of the first beneficiaries of adopting a metric layer and the efficiencies that it unlocks. And it was all the more rewarding to transfer that value to some of our stakeholders. Once again, I'm Brian Waligorski. It was a pleasure speaking with all of you today. I hope you have a wonderful rest of Coalesce, and I'll stick around on the stage in case you have any questions or want to discuss further. Thank you very much. See a question back there?
Yeah, hi. Thank you for the talk. That was really great.
Thanks.
I'm just wondering, how do you navigate having so many BI, I'll call them entry points for your users? Do they typically know what they want to use in advance? Like the finance team knows they want to use Excel? Or how much is it you trying to sort of influence them to use the tool you think is right for their use case?
That's a good question. And yeah, and you posed it really well. In the case of, say, like Google Sheets and Excel, I think that was an easy one because we knew that our finance team, that was like their second home was Excel. So we knew that was sort of an instance where we wanted to meet them. I say halfway, but probably more than halfway. Whereas something like, say, Steep, that's it was a brand new tool to me, brand new tool to most people. So for a tool like that, you want to be, at least in our case, we wanted to identify sort of, say, power users or maybe more adventurous data users to say, hey, do you want to take this relatively new tool for a ride, give us feedback. So it's segmenting personas out by both their use cases, but also sort of their appetite for how bleeding edge they want to be.
Gotcha. Thank you.
Yeah.
We have a lot of data scientists, users analyzing the data, and there seems to be a strong desire to be able to drill down to the raw rows. So I think one of the things that would make this a semantic layer a hard sell for me at my company would be that there's not a direct connection for the users looking at a metric to say, now I want to see the underlying data. Was that a concern you guys had, or did you have a solve for anything like that?
No, that's actually, it's funny because that's reminiscent of I'd say a constraint we ran up against recently. For us, it was not data scientists necessarily, but we have an experimentation platform that we wanted to, and you feed the experimentation platform your metrics, or rather your sort of raw atomic rows. And we wanted to govern that from the semantic layer, but for example, the save query exports require you to aggregate by certain dimensions, and the finest time dimension that you can aggregate by is day. So obviously, it's not atomic enough for that integration. So we needed to do a little bit of a hacky workaround where we can talk about it more later, or we can connect later about it. But you essentially have to trick the saved query export into thinking of your timestamp as being like a categorical dimension, and then so that just creates this, essentially, event level aggregation of your data that you can then feed into your in our case, an experimentation platform. So if you really needed atomic data and you really needed to be governed from the semantic layer, there are ways around it. It is a little hacky, but at least in our case, it was sufficient for our needs.
Is it mostly like a one-to-one back-end model to semantic metric?
One-to-one model to semantic model? Is that what?
Yeah.
Yeah, in fact, that's exactly the sort of thing that, what is this, my second point here, because this is exactly the sort of thing that I feel like we negotiated over and over again, and sort of maybe made decisions and undid decisions in several cycles. And yeah, I would say for the most part, we settled at, by default, your semantic models are in a one-to-one relationship with your metrics. And we found that when they weren't in a one-to-one relationship, then it probably required some refactoring of our modeling layer as opposed to our semantic layer. Yep.
How would you say, when your data warehouse, your team, your organization is ready to start using metrics in the semantic layer versus defining the same metrics just as SQL queries? Like, what are the preconditions to taking that step?
So as a data engineer, it was when I found that it was no longer sort of sustainable to be writing the equivalent SQL query for, say, what this YAML specification would produce. Because this, in the old world, this was probably a 500-line SQL query, incredibly brittle. This is the sort of thing that we were always attending to day after day. And so from a support overhead standpoint, we said to ourselves, if instead of having to come up with this join logic anew every time we want to slightly change this analysis or sort of expand upon it, let's just codify how tables are joined together. And then at that point, this was sort of the first thing that scaled in our activation of the semantic layer. Like we built a lot of saved queries first before using any of those other tools I demonstrated. So it's really, again, this is my perspective as a data engineer, but once you wanted to sort of draw down some of that technical debt of having all these very complex SQL, like denormalization queries.
You mentioned about sometimes you may require refactoring some models. So while you are doing this, how do you validate these models are unimpact to the production, like the dashboard report that this is totally still need to be, while you are doing the changing to adopting these models to semantic layers?
Well, in our case, we use and I think you're familiar with this. So as we were making modeling changes to our modeling layer, we wanted to make sure we could account for any changes to the data. We use a data impact analysis tool called Recce, which I'm a huge fan of. But what that does is make changes to your models and submit a pull request. You can then spin up a Recce instance. It'll give you a lineage chart of the models you changed, all the models downstream of those changes, and allows you to directly compare your production data sets against your CI/CD data sets and provide analysis of how that data is going to change. So in our case, that was sort of, and Karen as a developer for Recce, really appreciate that product. But yeah, so that was a key tool in being able to do that refactoring without being that refactoring while being able to also ensure our stakeholders that data wouldn't change unexpectedly.
Does that imply that you're then your CI/CD process is building like a ticket level version of all of your data outputs that you compare to prod?
Could you repeat that one?
So in some flow, like CI/CD workflows that I've seen, when you submit the PR, the system actually builds the table outputs for the whole ticket.
Mm-hmm.
So materialized in the database somewhere, you would have your prod branch, obviously, and then you would have a ticket branch with a ticket, say postfix, so it would be database name, postfix, ticket number, with all the artifacts under that, so that you can compare the two.
Yeah, so our architecture looked very much like that. Instead of ticket-based, it was just PR-based, but same sort of idea. Did I answer your question? Okay.
First, thank you.
Of course.
You talked about, in the future, looking at anomaly detection on the semantic metrics. Two things. I was curious, do you have a sense of who the consumers of those anomaly notifications might be?
Yeah, that is a great question. It's still very much in a nascent state, but at least personas in my mind, we have analysts who are subject matter experts in their space. They're bringing up the same set of dashboards every day, and they're again they're so deeply embedded in the context that they can look at yesterday's data and go, that looks strange, and then thus begins their sort of dive down the rabbit hole of, is this strange for a technical reason? Is it strange for a business reason? And then having to do all that exploration manually. And so ideally for us, we would love to have at least maybe the first few iterations of that investigation done in an automated way using our metric layer, just to generate better signal for our analysts so that they're not sort of constantly needing to look at their dashboard each day to flag potential data issues. Yes, so metrics are, so your metrics and semantic models are surfaced in the lineage chart in dbt Explorer. They might also be in dbt docs as well. That is the thing I'm most looking forward to as dbt adds features to both Explorer and the semantic layer to sort of improve the just the visibility of metrics in the Explorer. Because, for example, you can see the metrics in Explorer, but it wouldn't tell you, say, the aggregation that contributes to that metric. Moreover, saved queries consume metrics, but I don't think saved queries currently are not part of the lineage chart. I wish they were, because that's become like a huge, they're essentially like exposures in our system at that point. So we would love to get those to be first-class citizens in the lineage chart. You can't do it with dbt core?
Yeah. Can we explore things in dbt core as well?
So dbt core uses dbt docs, and I think at least the metrics are surfaced in the dbt docs web. Of course. Yeah.
I was wondering if you could elaborate more on the, like we use marks that are very normalized. So then kind of you mentioned normalization was key for you guys. If you could elaborate more on like why or what pain point that denormalized marks like we have might cause problems.
Yeah, good question. Let me think of a quick example. Okay, here's one. So in our case, we have a model that's page views, and previously it had been sort of slightly denormalized in that we were storing the device category or device type on the page view record, and because of that, say you were doing an analysis of both page views and engaged time, which in our case was in a different model, and you wanted to slice and dice by device category. Because the device category was stored on the page view record, it wasn't compatible with anything on the engaged time model. So you needed to, so in our case, think of it as being like, instead of a device category being stored on directly on the page view record, you want to create, say, a device category table or even a sessions table, and then you'll have a common foreign key from both your page views model and your engaged time model that join to this sort of common model that describes sort of an umbrella business process.
So you definitely have to rework a lot of like if we have all these marks, we'd have to rework them all probably.
Yeah, it's doable because like our first iterations of our semantic models use these denormalized models, but as we were pulling two metrics into a given analysis, those two metrics need to have a compatible dimension space if you're going to sort of be able to compare them directly against one another. Yeah.
Are you running into any performance issues or high compute costs with calculating everything offline with aggregation?
High compute costs. So, well, just as background, we're using BigQuery right now. High compute cost, not seeing performance issues necessarily. or not seeing high, I guess, compute cost issues, but we are seeing at the margin some performance issues. We have, when you have like a large number of metrics that are across a variety of different tables, maybe not this one, but we have a few that say have several dozen metrics that are coming from maybe about a dozen or so tables, and we're finding that we're running those save query exports, and they might take, granted these all are running overnight, but they might take like about an hour to return. So running into some performance issues there. We've been talking with the Semantic Layer team and the metric flow team about how to like best optimize it. And they've given some advice, things like pushing your, so you have filters in your metrics, and then you also have expressions in your measures. The idea is where you want to be able to push those filters into your measure expressions where possible, because that filtering happens sooner, and that has has been shown to improve performance. Of course.
Might be a little rapid, but do you think that the semantic layer is a stable solution to the kind of a timing issue between business, data, and developers/engineers? I feel like obviously I love this,
Mhm.
but the issues that cause the building of this, like for instance, why do we have a column named customer ID and one user ID, and it's unclear how those emerge? Is there a way that we can be more proactive, so this isn't just fixing what we have now, but also anticipating what else is going to come and making sure we don't have to keep adding to the semantic layer as business doesn't communicate exactly with, this is where it's getting rambling. But
No,
you know what I mean?
that is a great question, and it is resonating on a lot of things that I feel like we've encountered as well. Yeah, I mean, there's no substitute for consistent business processes, so that you can get sort of data that has a reliable signal to those business processes, and we haven't found a silver bullet for that. That being said, I feel like something that has been like very productive and valuable for us is when we sit down with the analysts and the other stakeholders and say, all right, we're going to define what's a web subscription. Like that, this was a good one for us. Like, what is a web conversion? And again, there are different stakeholder groups using different methodologies to come up with their derivation of web subscriptions. So if there are significant discrepancies with those derivations, that's exactly the point where you begin to like negotiate sort of a common ground there, is when you're doing that metric engineering. So yeah, I would say like engineering a metric in metric flow is pretty trivial. It's just a YAML configuration. There are only so many degrees of freedom there. But actually saying, all right, what features and models and business processes map to these, how do these business processes map to the data? I feel like that's when you begin to sort of cultivate some consistency about how your business like talks about these things.
It's always interesting because I feel like business will be like, hey, can you get me this? And I'm like, let me check the data if I have it, and then I have to go ask one of the developers, wait, did you think of this ahead when you were like, bringing the data in? And I think this could be a cool solution to actually doing that ahead, a little bit ahead of the curve. So if business already knows what they want, we can make sure that that data is flowing in, and we're doing that by having these kind of negotiations ahead of actually building things out. So I think that's another cool use case.
No, yeah, I agree.
Quick last one, probably. Great presentation. And always these types of investments require some sort of stakeholder buy-in at the beginning. But how have you approached quantifying the impact of this endeavor? Because it seems like it was a success, but for others, as they try to kind of sell, hey, we're still going to keep the lights on, but we want to actually invest in trying to change things.
Yeah, that's a good question. There are, I would say, a couple prongs in that approach. Again, one of which is again the save query. So this allows you to use the semantic layer without adding any additional tools to your tool set. So this is something this is a change that can happen pretty much internally. As for using other tools, I would say one of the ways it's been easier to pitch to the business is that all those tools I was showing earlier, Contrast these with like the more sort of monolithic legacy data tools out there where you're buying a giant, multi-year enterprise contract. A lot of these, you're buying them on a per seat basis. You're saying, so instead of saying, hey, I need, however many thousands of dollars for a 3-year commitment to whatever tool, all these are generally, hey, can I have 5 data product managers that need, that want to interact with the BI tool. Can we buy 5 monthly seats of Steep? Or we have data analysts who need to compare semantic layer cells and SQL cells. Can we get 5, 10 additional seats of Hex? So I think that rhetoric was helpful for me to pitch to the business about investing in this because it is a little bit more, you're able to be a little bit more fine-grained about how you're allocating sort of where the resources and tooling, or where the resources are going with respect to tooling.
And what about the benefit, right? Because clearly there seems to be less time spent managing fragile, code base, right? So have you been able to kind of quantify like that direct complexity?
Yeah, I would say one of the success stories is, granted, I was saying how we don't want dashboards to be like our only currency as far as a data team goes, but our time to delivery for dashboards has gone down significantly by adopting the semantic layer, because the sort of back and forth between data engineers and analysts has gotten so much more efficient, because instead of talking around like big SQL queries and sort of trying to guess what analysts want to see in a given analysis or presentation, you're able to pull up any of these arbitrary tools that we have hooked up to the semantic layer, do a quick analysis with metrics and dimensions, and say, is this what you want to see in your dashboard? And from there, if the answer is yes, well then you could just convert that into a saved query spec, and then you're off to the races. And if not, you're able to talk about what the distance is between what they're seeing and what they want to see in pretty specific ways. So even though I said we didn't want to go from analysts create dashboards to analysts create dashboards but faster, it is a side effect of this adopting this approach as well.